This is the nomenclature of acids, and the first thing we should do is define what an acid is. So it's going to be hydrogen plus any nonmetal, and we have two types. So a binary acid is going to contain no oxygen, and an oxyacid is going to contain an oxygen. So we have different rules for naming each one of those. Let's start with binary acids. So for this one, we're going to have hydro at the beginning of all of the names. Right? Again, these don't contain oxygen. The base name of the nonmetal, so just like in the naming, the nomenclature we've done before, like for example, brom or chlor. So for those are going to be our base names. And we're going to add ic to that. We have a space, and then we write the word acid. So for example, we have hydro first. Our anion is bromine, so our base name is brom. We're going to add ic to the ending. We have a space, and then we write acid. So fairly straightforward using information that we've already used in nomenclature. If we have an oxyacid, on the other hand, the name is going to depend on the ending of the polyatomic ion. So again, we need to know those polyatomic ions because those subtle differences are going to change the way we name acids. So for example, if it contains a polyatomic ion with the ending ate, it's going to differ from how we name those with the ending ite. So let's start with ate. We're going to have the base name of the anion. And when I say anion, we're talking about not the oxygen, but the other nonmetals, so nitrogen or sulfur in this case. And we're going to have a space. Okay, so for these, the ending will be ic. Okay, so we have 8 is our ending for the polyatomic. That means in the acid, it's going to correspond to ic. We have a space and write acid. So let's look at the first one. We know this is nitrate, and that's where we get which type of oxyacid it is. So to start, we're going to write the base name for nitrogen, which is nit, and then we want ic because it is an 8 polyatomic ion. We have a space and rewrite acid. So this will be nitric acid. For the next one, H2SO4, one thing we may wonder is why we have 2 hydrogens here. And that's because each one of those hydrogens has a +1 charge. So for example, we know nitrate has a -1 charge. So the +1 balances out. We just need one of them. Whereas sulfate has a -2 charge, so we need 2 of those H's to balance it out, to make it neutral overall. So when we're naming acids, the base name for sulfur is just going to be sulfur, right? Since we have sulfate, it will be sulfuric. We have a space, and then we write acid. Okay. So let's compare that to some polyatomics that have ite as the ending. So it's going to change one thing in the name. If our polyatomic has the ending ite, we still have our base name of the anion, but instead of ic, like we saw above, we're going to write us. And we have a space and acid. Okay, so for comparison's sake, let's choose 2 that are very similar. This is going to be nitrite. Okay, so we have our base name is still nit, but we have us because we have ite as the ending, and we add acid. Okay, again, we know that nitrite has a -1 charge, so it's balanced out with the +1 charge of the hydrogen. So our formula makes sense. Similarly, we have sulfite. Okay, so we said our base is going to be sulfur when we have that element involved in our acid. And our ending now is going to be us. We have a space and acid, so sulfurous acid. Let's look at a few more examples. So for our first example, the polyatomic that we have is acetate. So since it has an A ending, it tells us that our ending in our base has to be ic, right? Just for practice, we know that acetate has a -1 charge. We just said that these hydrogens on acid have a +1 charge, so the formula makes sense, it's balanced out. Our base is going to be acete, and then we said our ending for that base has to be ic. We have a space and acid. So acetic acid, or better known for us, is vinegar. So it's the ingredient in vinegar that makes it sour. For our second example, we have a binary acid, meaning it doesn't have any oxygen in it, so it has to start with hydro. For iodide, or anion, our base name would be iode, and we're adding ic. We have a space and acid, hydroiodic acid. Okay, the formula makes sense because we know halogens like to have -1 charges, and we said our hydrogen is +1, so it's balanced out. The last example, we have phosphite. Okay. And since our ending is "ite" on this polyatomic ion, we want us, our base name. Okay. Phosphite has a -3 charge, so it makes sense that we need 3 of these hydrogens to balance it out. Right? So our base name for phosphorus is going to be phosphor. Okay. We said our ending is going to be us, and we want a space and acid. So we have phosphorus acid.